So let us say you want to find the n roots of unity. Okay. So if I have z power n equal to, I'll do it in two cases. First of all, I'm doing the simpler case. Simpler case mein, let us just find the roots of z power 1 equal to 1. Okay. We want to find the roots of z power n equal to 1. Okay, by the way, what can we write 1 as in terms of complex numbers? In terms of complex numbers, what is 1? 1 in terms of cis. Can someone tell me?
This is 0.
Very good. Cis 0. But is that the only value for which you get 1? Okay. In fact, it will be any multiple of 2 pi. Any yeah,
I
it will
think
be any integral multiple of 2 pi will give you 1. Okay. Where k can take any real number. Okay. But now you see k belongs to the integer. But now using De Moivre's theorem, can I tell z equal to cis of 2k pi divided by n? बोल सकते हैं क्या? Can we say this?
Yes.
Yes, sir.
This becomes very interesting. Why, you see, see, we said k is an integer. What are the integer values it can take? Let us start with 0. Okay? And let us see what all values it can take. So when I say k equal to 0, see, you're actually going to get a specific root for this equation. What is that root? When k is equal to 0, we say that z will be equal to cis 0. What do you mean by cis 0? One, right? When k equal to 0. When k equal to 1, what will I get? I get z is equal to cis of, can someone tell me? 2 pi by n. Okay. When k equal to 2, I'll get 4 pi by n. So on and so forth. Till where can I go? I can go till the point that, okay, let us say we reach the point k equal to n. After you go for a long time, let us say you reach a point where z is equal to k equal to n. If k is equal to n, what will I get? I'll get 2n pi divided by n when k is equal to n. But what does this mean? What does this fellow mean? This is again 1, which is something we already wrote. This is not something new. It is not something distinct. See, these two are different things. This is also distinct. But this is something that we have already written. Okay? Okay.
Yes, sir.
So very interesting. You see, we are starting from k equal to 0 and we're going till k equal to n minus 1. Till this point, we are going to get distinct roots for this equation. How many roots are we getting? From 0 to n minus 1. How many roots will you get? Zero to n minus 1. How many roots? Right? 0, 1, 2, so on till n minus 1. How many numbers are there? How many roots are these? How many roots are there? 0, 1, 2, 3, so on till n minus 1. How many roots are these?
n.
N roots. Thank you. So these will be the n roots of n distinct roots of unity. See, why am I telling n distinct roots? After this also, for other values of k also, you'll get the answer, but you'll get the repeated answer. Okay? After n minus 1, if you go till n, then again you're repeating the same cycle. Again you go to this root, then you go to this root, then you go to this root, so on. Okay? So this is very, very important. So the solution to z power n is equal to 1 is nothing but you have n roots. Now you see, observe, all of them are cis something. So all of them are having a magnitude of 1. All of them are unimodular. So that means the answer will be you'll have n roots. Now one more thing, if you observe, they're all equispaced. For example, what is the first root? 1. What is the second root? Cis 2 pi by n. What do I mean by 2 pi by n? That means it is something which would lie on the same circle, on the same unit circle. Let me make it a little bigger. Okay. So this will be the next root. This will be your cis 2 pi by n. What will the argument be of cis 2 pi by n? This will be 2 pi. Okay. Then this will be cis 4 pi by n, where this angle will be 2 pi by n. Okay. This is 4 pi by n. So on and so forth. If you keep plotting all the points, you'll fill the circle, and all of them will be equispaced till this point. This will be your cis 2 pi into n minus 1 by n. So for all values of n, you will always get the roots lying on this unit circle. Okay. So that is important. And there are two more important points to consider here. Whenever I say z power n is equal to 1, the sum of roots will always be 0. See, because this is a polynomial, z power n minus 0 times of z power n minus 1 plus so on. You can write this in this format. Minus 1 is equal to 0. What is the sum of roots? Sum of roots is always calculated using this coefficient. Therefore, the sum of all these roots will always be 0. Okay? So that is the first point. First point is sum of roots of unity plus 1. Second one, product of unity. What will the product of roots of unity be? Anyone?
-1.
Not always. It will actually be -1 to the power n minus. What is the reason? Many ways of understanding it. One thing is, if you just multiply, these are the n roots of unity. If you multiply all of this, then you'll get the answer 0, and except for 0, you're getting n minus 1 roots. You get it? For example, let us multiply all the roots. I'm multiplying all the roots here. What are the roots? I'm calling the roots as alpha 1. Let us say we have n roots of unity. Alpha 1, alpha 2, alpha 3, so until alpha n. Let us say these are the n roots of unity. So what is alpha 1? First root is cis 0. Second root is cis 2 pi by n. The final root is cis of 2 n minus 1 pi by n. Okay. Now if I multiply all of this, what will I get? I'll get, see, what do you mean by cis? This is nothing but e power I times of 0. This is e power I times of 2 pi by n. So on and so forth. This will be e power I times of 2 into n minus 1 times of pi divided by n. If I multiply all of this, what will happen? Bases are equal, so powerful add themselves. E power I times of, now 0 doesn't count when you're adding. So 2 pi by n plus next term will be 4 pi by n. In the term after that, so on till. So what is all of this? This is nothing but e power I into, I can take 2 pi by n common. And then we're adding n minus 1 terms from 1 to 2, you're going till n minus 1, which is nothing but e power I times of 2 pi by n. What is this sigma 1 to n minus 1? N into n plus 1. So using that formula, you have n minus 1 into n. So which is nothing but e power I into 2 pi into n minus 1, which I can again write as e power I 2 pi whole power n minus 1. Yeah, you'll have a by 2 here. N into n minus 1 by 2. By 2, by 2. So no 2 over here. No 2 over here. So this will be minus 1 power n minus 1. So this will be the product of roots. Okay? You don't have to do all this stuff. You just remember simply. For example, x square equal to 1. The product of roots will be plus 1 into minus 1. Minus 1 आना चाहिए. Cube roots of unity. 1 into omega square. Omega cube. Omega cube. आपको 1 आना चाहिए. So remember, the formula is not difficult, but this is the proof. Okay, so these two are also very important points which will help you in many problems. Okay.